We will learn about sum of products and their solutions using Karnaugh maps, that what we also call them the K map. Let's start first understanding what is the meaning of sum of products. To understand this concept, let's start with a very simple understanding. We know that, for example, that if we do have an AND gate, then this AND gate can be like this representation, and it has two inputs, A and B. Then the output of this AND gate is A times B. So now you can see that this actually gate is giving us a Boolean expression in terms of the product of these two inputs, or you can also call them the variables. And if, for an example, we have another AND gate, and this AND gate has three inputs like this, that, for example, these inputs are B, C, and D. The output of this gate, that will be product of B, C, and D. And if we add one more, let's say we do have a three AND gates, then now our here the inputs are the variables are, let's say, are the C and D only. And now we have three AND gates. And the output of the third gate is the product of C and D. Now, if for an example, I connect these three AND gates with one OR gate, then you would see that what will happen, that here the output of the first AND gate is an input of our OR gate, and similarly of the second one, and also of a third one. What will be our output of this gate? The output of this gate will be that the A, B plus B, C, D plus C, D. Now you can see here that it is in fact the sum of three product terms. So our this resultant Boolean expression, it is in fact written in the form of sum of products. So this means that an SOP, meaning the sum of products expression, can be implemented with or and two or more than two AND gates. So the different examples we can take for the sum of products can be following, along with this example, that, for example, we have A, B plus A, B, C. Or we can also take for an example that we have A bar B plus A bar B C bar plus A C. So these are different examples of sum of products. And here there are a few important concepts related to sum of products that we always must keep in our mind when we are solving the problems related to sum of products, that are the following. And for example, the first thing that we need to know about these sum of products expressions is the domain of these expressions. So what is the meaning of domain? So if, for an example, we actually look over this example, which we have with the three and one OR gate, then we can see that in fact there are four variables A, B, C, and D. It means the domain is A, B, C, and D for our this initial expression. But in case of here, our example number one, the domain is A, B, and C only. And in case of this second example, our domain is A, B, C as well. So this is the domain. That is the very first thing that we must keep in our mind. The second thing is the following, that you can see in this second example that this in the first product term, we have A with bar, and in the second product term, we have A and C with the single bars. So here in some of the products, we can never have extended bar. For an example, that if we do have here AB and we have overall bar on this product of AB, this is not allowed in some of products. So only the single bar is allowed. For an example, that we actually can have A bar, B bar instead of the single bar on this product. So this term is not allowed, but the term with the single bar is allowed in this sum of products. Now, the next point that we need to understand, the standard form of the sum of a product expression. So what is the meaning of a standard form? Standard form is the following. Let's go to understand that. Okay, let's try to understand standard form of an SOP expression. So standard form of an SOP Boolean expression. For an example, we have here the sum of products AB plus BC. First, let's take a very simple example here. So this expression is in fact written in sum of products, that you can see that there are two product terms and we are adding them up. So certainly they are sum of products. But this expression is still not in a standard form of SOP. Why? Because we can see that the domain of this expression is A, B, and C. So the standard form is that in each product term, we should have all these variables in actually our each product term, meaning that we must have A, B, C. Even if some actually have the bar or not, that is also actually included. This is also possible. So it means that here we can see that in the first term, the C is missing, and in the second term, A is missing. How we can include these with our this expression? We know that for an example, if I do have this product term AB and I times it with 1, then our answer will be simply again AB. So it means that it is not going to change if I would multiply it with 1. And here, now you can see that if, for example, I multiply it with the C plus C bar, because the C plus C bar, that is also equal to 1. So now our this single product term, it will actually change into ABC plus ABC bar. And similarly, in the second term, you can see that we do have, for example, BC. Then now we need to times it with the A plus A bar, which is equal to 1. So it would not change your expression, times it with the product of the B and C. So then here we are going to get that the A B, C, and plus A bar B, C. So in this way, you can actually split your term in two terms, or in other words, you can say that you can actually put all the domain in each product term. So here, now if, for example, we put these two expressions back in the first, our answer is A, B, C plus A, B, C bar, and then plus ABC. ABC is already here, so we are not going to take it twice. So we will have A bar, B, C. Now, this our expression one bar is actually in standard form of SOP. So we always need to have our SOP in its standard form. What standard form is that each product term must have the full domain of our this expression. So domain means that the number of variables that we have in this expression. So three variables. So in each term, now we have three variables. Let's solve one more example to convert a simple SOP into its standard SOP expression. Okay, let's take an example. So our example is following, that we do have an expression, and it is A, B bar C, then plus A bar B bar plus A B C bar D. Now, if we look carefully, we can see that in our this expression number one, the domain is actually the following, that A, B, C, D. A, B, C, and D. So it means that we should have all these three variables or inputs in each product term. And we see that in the first term, we have only three. In the second term, we have only two. So how we can convert these into the standard form? The process is the following. Let's take the first one, the A, B bar C. So we are missing D. So we will multiply it with the D plus D bar. So what the answer is, now they are going to multiply inside this bracket. So we have A, B bar, C into D plus A, B bar, C, D bar. Now we take the second one. This second one is A bar, B bar. So first include here C term by multiplying it with the C plus C bar. What will be the result? A bar, B bar, C plus A bar, B bar, C bar. So you see, each actually the variable has its own single bar. So these are allowed. So if there will be one extended bar, then that is not allowed as sum of products term. Now we can see that we still have three variables, so domain is not complete. So we are still missing D. So with these both terms, we are going to multiply with the C D plus D bar. So the result will be following: A bar, B bar, C times D plus D bar. Now plus A bar, B bar, C bar times D plus D bar. Now expand the brackets And our answer is the following: A bar, B bar, C, D plus A bar, B bar, C, D bar plus A bar, B bar, C bar, D plus A bar, B bar, C bar, D bar. So now our old terms are ready to actually go back in the first expression, and then we will actually have it in its standard form. And the standard form is the following now. So first, this A, B bar, C is actually now is A, B bar, C, D plus A, B bar, C, D bar. And the second term now has the four terms actually. So this will be plus A bar, B bar, C, D plus A bar, B bar, C, D bar plus A bar, B bar, C bar into D plus A bar, B bar, C bar, D bar, and our last term, which is A, B, C bar, D. Now you can see that these three terms are actually converted into seven terms. What both of these expressions are the same. What we just actually converted our this simple SOP expression into standard SOP expression. And why actually we are converting our SOPs into its standard form? Because this standard form is required for having our Karnaugh maps, meaning the K map. Now we move forward to understand that how to develop Karnaugh maps or the K maps. Okay, now we move towards understanding Karnaugh maps with some examples. So before going to solve some examples for K maps, let's try to understand that what K maps are. K-maps actually provides a systematic method for simplifying Boolean expressions, and if properly used, will produce the simplest SOP expression possible. I am using this term SOP, sum of products, because our today's lesson is mainly for SOPs only. And in the next one, we will discuss POS, the product of sum. And in case of the Karnaugh maps, and this is actually different than truth tables. In truth tables, what we do, we actually use columns and rows. What in Karnaugh map, it is in fact an array of cells in which each cell represents a binary value of the input variables. For an example, that if, for example, we have a truth table, we actually mostly actually arrange our inputs in the form of columns and the rows. For example, if we have A and B are our inputs, and here it is our result, and we do actually this kind of things. What in case of the Karnaugh map, what we do, we actually arrange this map in the form of cells. And the number of cells, it depends on the Boolean expressions domain. For example, that if domain is actually based on the three inputs, then in that case, we will have actually the number of cells 2 power 3. Similarly, if our domain is A, B, C, D, then number of cells will be 2 power 4. And similarly, if we do have just only two variables A and B, then our actually the size of the cell will be size of the map will be 2 power 2, meaning the number of cells will be 4 in that case. But in case of three input variables, our actually number of cells are 8. And in case of 2 power 4, meaning the four input variables, then the number of cells will be 16. First, let's start with some examples of three variables. So how we arrange these map. So for example, we have the domain of our Boolean expression ABC. So in this case, we will have total 8 cells. And 8 cells, we can arrange them in the following way that, for example, the four along the vertical direction and two along horizontal direction, like this over here. So now we have here 8 cells. And at the corner, just put the line just to differentiate the variables. So here we have a C and we have a AB. So we go from bottom to up A, B, and C. And the first value is a 0 and the second value is a 1. And for these two, we start with the 0, 0, 0, 1, then 1, 1, 1, 0. So these four possible values, and for C, these two possible values. So now what we do, we actually will arrange here all our input values depending on the expression. So here, actually, what happens, let me actually also tell you that what values will be placed over here, that if we do have this our 8 cells K map, then what would we have? We have this situation like this, and now we will actually put the values over here. For an example, in the first cell, what we do have, we have a AB, which has the 0, 0 value, and C also have a 0 value. Then over here, we have a 1, 0, 0, 0, 1, 1, 1, 1, 0. So this sequence is always like this. So now what actually first cell belongs 0, 0, 0 value. So it means that there here we will have A bar, B bar, C bar. And in the second cell here, what we do have AB 0, 0. So it means we have A bar, B bar, and the value of the C is 1. So it will be C. Now we have a 0, 1 values for A, B. So A is 0, so it will be A bar, and B is 1, it will be B, and C is 0, so C bar. And in the next one, again, A is actually 0 value, so A bar, B, and C as it is. And the next one, we have A1, B1, so it means AB, and C0, so C bar. So next one, A, B, and C as it is, because the value of C is 1. And here A is 1 and B is 0. So B bar, C bar. The last one will be A is 1, B 0, B bar, C is 1. So we will have the values like this in this, you can say the table. And that is actually the K map. Now, what we do, we actually take an example, and the example is again of our domain ABC expression. So let me just put the other blackboard, and here we have our Boolean expression as following. For an example, we have A, B bar, C plus A bar, B, C plus A bar, B bar, C plus A bar, B bar, C bar plus A, B bar, C bar. Okay, now what we actually need to have, we need to have a 8 cells table because here we have only 3 inputs. So we have actually the domain of A, B, C, 3 variables. So our map is following like this, that 8 cells again. Before filling it, what you can do, you can also actually find the values for each product terms of this SOP Boolean expression. So let me first complete our table. So our table is here. Okay, let's start putting the values. Here we have a 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. First term is A, 1 value, B bar, 0, C, 1. So let's find this one. Where is it? 1, 0, 1. 1, 0, 1. So we have actually 1 over here. Then the next product term is A bar. It is 0. B is 1. C is 1. So it means 0, 1. 0, 1 here. 0, 1, 1. 0, 1 and 1. So we are over here. So actually, wherever this product term belongs, our output will be 1. Now we have A bar, which is 0, B bar 0, C is 1. So 0, 0, 1. So here we will put 1. The fourth term is A bar, B bar, C bar. So all are 0. So 0, 0, 0. So it's a first cell here. So we have A, that means 1, B bar, C bar, 1, 0, 1, 1. So here, this is our actually the K map. First, we will try to understand the K maps and filling the values in K maps. So here we have actually our these all Boolean expressions of product terms. Then we have 1, 1. So these 3 cells where we do have nothing, actually there we will put 0, or we just leave them as it is. Now let's move to solve one example of domain 4, where we do have A, B, C, D, 4 inputs or 4 variables. Now let's take an example where our domain is A, B, C, D. So our first term of sum of products Boolean expression is A bar, B bar, C, D plus A bar, B, C bar, D bar plus A, B, C bar, D plus A, B, C, D plus A, B, C bar, D bar plus A bar, B bar, C bar, D bar plus A, B bar, C, D bar. Okay, good. So now what the domain is? A, B, C, D. So we have 4 variables. So 2 power 4 actually the dimensions of our K map. So 2 power 4 is 16. So this means that our actually this time the table will have 16 cells. How we would do this? Let's we have this our table 2 And now these are 4 here, and also 4 to the other dimension, like this. And now we actually put the values here: A, B, C, D. 0, 0, 0, 1, 1, 1, 1, 0. Similarly, vertically 0, 0, 0, 1, 1, 1, 1, 0. Okay, now let's actually look at each term. The first term, A bar 0, B bar 0, C 1, D 1. So A and B 0, 0, C and D 1, 1. So our actually one value would go over there. Second term, A bar 0, B 1, C bar 0, D bar 0. So this is 0, 1, 0, 0. So our one value will go here. Third term, A, B, C bar, D. So 1, 1, 0, 1. 1, 1, 0, 1. So our answer is over here. Then the fourth term is B1, A1, B1, C1, D1. So 1, 1, 1, 1. So our one value over here. Next term is A1, B1, C0, D0. So 1, 1, 0, 0. So 1 will go over here. Next term, A bar 0, B bar 0, C bar 0, D is 1. So 0, 0, 0, 1. 0, 0, 0, 1. So 1 will go over here. Then the last term, which is A is 1, B bar is 0, C is 1, and we have D bar, it is also 0. 1, 0, 1, 0. 1, 0, 1, 0, we got here 1 over here. Okay, so now this is our K-map of this Boolean expression. So what is the method? First, we will look at the domain of this SOP Boolean expression. So here it is A, B, C, D. So we have 4 variables. So number of cells will be then 2 power 4, meaning 16. So 16 means this will be 4 by 4 square table of our these actually the cells. And we know that each cell is actually belongs to the binary value of our system. So here what we do have, we will have AB and CD. So product of AB and product of CD. Values will start from 0, 0, 0, 1, 1, 1, 1, 0. And similarly to the other side, 0, 0, 0, 1, 1, 1, 1, 0. And after this, we look each term, and if we have the bar, then corresponding value 0, and C and D without bar, they will have actually value 1. So actually here you can see that what is in principle happening, that we have this first product term. So in this product term, that this product term can give us the value 1 only if A is 0 and a B is also 0, because A bar and B bar means a 0 bar, that will be 1, 1, 1 times 1 times 1 times 1, answer will be 1. So that's why when we do have a bar, then that will take 0 value. So here we have our actually this K map, which is ready for the solution. Now, the next step is that how we can find the solution using these K maps. It's a very simple, very easy. For that, we need to group the cells. How we do the grouping, let's understand. Okay, now our task is grouping. So how we should group? So there are few very important rules that we must always keep in our mind in case of grouping. So let me change the color. So for grouping, what do we need to do? That one group of these values should have the maximum numbers of 1, 2, 4, 8, 16, so on, meaning that the number should be in the form of 2 power n. So n0, 1, n1, 2, n2, 4, n3, 8, n4, 16, and so on. So the biggest group will be 16 in case of a four variable map, as in this example. And in case of a three variable map, so maximum biggest group will be with the 8 elements, and that will be only one over there. Then the second point is that in each cell in a group must be adjacent to one or more cells in that group. But all cells in the group do not have to be adjacent to each other. So meaning that here, that first, if we look over here, then we can see that we can actually group these two. So we have this one group. So they are adjacent to each other over here. And now if we look, this is horizontal group, and where we do have two. And if we look this other one here, 1, 1, 1, there are three, and these three, they cannot actually make one group. What? 2, 4, 8, 16. So then our one group would be over here, and one group will be over here. And this one is alone, so that will remain as it is, which fulfills this one. Okay, now what the rules are, that we will have either 1, 2, 4, 8, 16 cells in 16 ones in one group. And we also need to maximize the size of a group. But here you can see that there were three next to each other, but three is not possible, two. So two can be only the biggest group, and one left behind. So it is also a part of a group. So in some cases, we can also overlap, that we will understand in a minute. So now what we can do, we can write the solution for these groups. So look within the group, that what we do have here, that our variables are A, B, C, D. Within this group, our A and B, they are persistent, meaning that their values are not changing. So we have A value 0, so A bar, B value 0, B bar. And now look, the value of the C, C changes from 0 to 1, so this will not be included. D value is 1, D value 1, so D is included, so answer D. Now in this loop, our A value changes, so out. B value is persistent, which is 1, so we will have B here. C and D both are 0 and persistent, so C bar and D bar. Now the third loop over here, here we can see A and B are persistent with the 1 value. So A is 1, B is 1. Now let's have a look at C changing. D is not changing, but its value is 1. So it over here. Then this fourth group, which is 1, here that it is only one element. So A is 1, then B 0, C is 1, D is 0. So D bar. So then for this expression where we have 1, 2, 3, 4, 5, 6, 7 uh, terms, product terms. So our simplified expression will be that A bar, B bar, D plus B, C bar, D bar plus A, B, D plus A, B bar, C, D bar. So only these four terms that we left behind. So this is the simplest form of our this result. So now we can take a few more examples where we can draw only the tables, and then we will try to find the groups and the solutions as well. Okay, now let's solve a few more examples. So first example is for three variables. So domain is ABC. So our this expression is like A bar, B bar, C bar plus A bar, B, C plus A, B, C plus A, B, C bar. So you see, we have domain of A, B, C. So we will have this 8 cells K map. And in this case, we will have only 2 power 3 cells, meaning 8 cells. 4, you can put them vertical and 2 horizontal. So these are our total 8 cells. So lower AB, because we have a 4 here and C over here. Now, what the method is? A bar, so value should be 0, B value should be 0, C value should be 0, and 0, 0, 0. We should also write here. Then we will remember 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0. So our 1 over here. Next is A bar, meaning A0, B1, C1. 0, 1, 1 over here. Next one is 1, 1, 1. So we will have 1, 1, 1. So 1 would go here. Then 1, 1, 0. So 1, 1, 0, 1 is over here. So now here we can see that we have this alone one, meaning that this one has no any neighbor. So it is actually a group in itself. This one has a neighbor, and so we can make a group of 2. So a group of 2. But this one here is alone. So this can actually make a group. And in that case, we can overlap with the one common element between these two groups. So now what will be the solution? So this group is going to give us the solution. So A and B are persistent. They are not going to change their value. So A1, B1. What is happening to the C? C is changing its value along this group. So that is not the answer, meaning that will not be included. Now, in this group, you can see A is changing, but B is the same. So B1, C is persistent. So C is also 1. And then over here, what we do have A, B, same, C, same. So A, B, C, all are with the 0 numbers. So then it is actually A bar, B bar, C bar. So our this solution is A bar, B bar, C bar plus BC plus A, B, like this. So now what we can do, we can actually, without writing a Boolean expression, what I do, I actually write here a table, and in that table, I put some values there to understand a little more for open loops. So here we have again a three variable map. So after this last three variable map, we will go to the four variable maps A, B, and C. So 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Now, for an example, that what we have 1 over here, 1 over here, 1 here. And then similarly, we have 1 here, 1 here, and 1 over here. Now you can see that here, these two over here and here, they can make one group with two. What if we look the last row, here we also have two ones neighbor. So in that case, if these two combine together, they can make the biggest group with the four elements. So in this case, what we will have an open loop, or you can say open group, open loop. We call it loop actually, open loop here, and that is coming over here. So this actually loop is an open loop. It is going over here. And then you can also see that what is happening, that this one has actually the neighbor over here. So it will have overlap over here. And similarly, this one will also have this neighbor. Now, let's write first this biggest, because we always want to have a biggest group. And for that biggest group, so we will actually use the concept of open loop from this to the bottom ones. So we have four elements this time in this group. So now you can see, look in this biggest group with the four ones, that A is 0 here, A is 1 here, so A is not included. Then if we look B, B is 0, B is 0 here, so then B0, B bar. So if we see here that the C is changing, of course, within this from 0 to 1, so answer is only B bar. Let's have a look for this loop. Here, A is not changing, A is 0, so A bar. B is going from 0 to 1, so B changed out. And C is 0 for this loop, and we will have a C bar. Now, go to the third loop where our A is 1 and it is not changing. So B goes from 1 to 0. So we are not including B, and C is also 1 within this. So AC. So this is actually the solution of this table, which is A bar, C bar plus B bar plus AC. Good. So now we solve a few more examples from our actually the 16 cells K map that is more important. Okay, now we have a Boolean expression which is written in SO form, meaning sum of products, and that is A bar, B bar, C bar, D bar plus A bar, B bar, C bar, D plus A bar, B, C bar, D bar plus A bar, B, C bar D. Now, plus A bar B, and we have C and D, plus A bar B and C D bar. So then we have a plus A B bar, C bar D, and last term is A B bar C D. Okay, so here we can see that we will have a 16 cells K map. So here we will actually draw the 16 cells, for horizontal, for vertical. Then we have this situation over here. So 1, 2, 4. Similarly, 1, 2, 4. So now let's write the values A, B, C, D, 0, 0, 0, 1, 1, 0, 1, 1. So 0, 0, 0, 1, 1, 0, sorry, this is 1, 1, 1, 0. So 0, 0, 0, 1, 1, 1, 1, 0. So remember always this sequence. So now we actually give the values. So A bar, so 0, 0, 0, 0. So our 1 is here. So 0, 0, 0, D without bar, 1. So 0, 1, 0, 0. So 0, 0, 0, 1, 1 is here. 0, 1 over here, and 0, 0, 1 here. So A bar 0, B is 1, C bar 0, D is 1, 0, 1, 0, 1. So 1 over here. So now A bar 1, A bar 0. So B, C, D are 1, 1. So 0, 1 and 1, 1. So 1 is going over here. Then the next one, let's have a look. So A bar 0, B 1, C 1, D bar 0, 1 and 1, 0. So 1 over here. So next one is A. A is 1. B bar 0, C bar 0, D is 1, 1, 0, 0, 1. So 1 is over here. And the last one is A is 1, B bar 0, C is 1, D is 1, 1, 0, 1, 1 we will have over here. Now, let's have a grouping. And for this, you can see this one has a neighbor over here and also two neighbors over here. And we will make one loop with the 4 elements because we want to actually make biggest group. So this is our biggest group over here. Then now you can see that our next group is 1, 2, 3, 4. So these two elements are overlapping this time over here. So our next, actually the loop is over here. And then these two are also neighbors. So we can actually make a group of 2 ones. So these are our 3 groups, in fact, over here in this. Now let's write the solutions. So first group over here, A is not changing, it is 0, so A bar. B goes from 0 to 1 out. So then here, if we look carefully, that what is happening, C is 0, so C bar within this loop, what? D changing from 0 to 1. Then we go to this loop here, 0, 1 is persistent for A and B. So A bar B. the value of the C and D both are changing. And then for this third loop, here A is 1, so A, B is 0, B bar. So you can see C changed from 0 to 1, but D is still 1, so D is over here. So then for this expression, our actually simplified expression is A bar C bar plus A bar B plus A B bar D. Now you can see this is a simplified solution of our this very long SOP Boolean expression. But result is also SOP, but it is just with only three terms. So this is actually the advantage of K maps. Let's solve one or two more examples of group. Okay, let's solve one more example. So in this example, we have this a very long SOP Boolean expression where we have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms. So first we need to prepare our map. So here we can see the domain is A, B, C, D. So four variables. So 2 power 4, 16. So we will have K map with the 16 cells. So here again, four horizontal and four vertical cells. So it is a square map. So we will have this situation, 1, 2, and 4, 1, 2, and 4. So A, B, C, D. A, B, 0, 0, 0, 1, 1, 1, 1, 0. So 0, 0, 0, 1, 1, 1, 1, 0. Now, we now go to the first term, A bar. So A 0, B bar, 0, C bar, D bar, 0, 0, 0, 0, 1 over here. A bar, so this is 0, B1, C bar, D bar, 0, 1, 0, 0 over here. So this is A1, B1, C bar, D bar. So 1, 1, 0, 0 again over here. So next is A is 1, B bar, C bar, D bar. So 1, 0, 1, 0, 0 over here. Next one, A bar, 0, 0. So C is our 1, D 0. So 0, 0, 1, 0. So we have 1 over here. Then A bar 0, B 1, C 1, D bar, so 0. 0, 1. This is 0, 1 and 1, 0 over here. Then next we have A, B, C, A1, B1, C1, and D bar, so D 0. 1, 1, 1, 0. 1, 1, 1, 0 over here. Then A is 1, B bar 0, C is 1, D bar 0, 1, 0, 1, 0. So 1 is over here. So next one, A bar 0, B 1, C bar 0, D 1. So 0, 1, 0, 1. So we will have over here. Then A, B 1, 1, 1, 1, C bar 0, D is 1. Then 1, 1, 0, 1 over here. A1, B bar, so 0, C1, D1, 1, 0, and 1, 1. So this we will have over here. Now let's write the groups, meaning develop the loops. So you see that we have these 4 in this row, 4 in this row. And then what we can do, we actually can have this group of four, and this group of four, but they are in fact also at a very left and very right, so they are also neighbors. So we can have open loop. So here we have a open loop, and then here we also have an open loop. Okay, then here we can see these two are neighbors, but these two neighbors also have two more neighbors. So we can make a group of four because we always want to have the biggest group. What the numbers can be 1, 2, 4, 8, 16. And this one also have a neighbor. So we will overlap over here with 1. Now, let's write the solution for this. So this loop with 8 cells, you can see that our A changing, B changing, C0, A1. So this is out. D0, D0. So that is the only which survives. So D bar. Now we can go to this second loop that has 4 cells. So A changes, B is 1 as it is. So C is 0. So C bar. D goes from 0 to 1 out. And then this third one here, A is 1, B 0. So B bar. So C is 1. So C here, and D goes from 1 to 0 out. So our solution for this SOP Boolean expression is D bar plus B C bar plus A B bar C. So this is our simplified solution of this SOP Boolean expression using K-map. I hope it will help you to understand that how we can prepare the K-maps and then grouping the elements, grouping the cells with ones. And the rule is very simple that we are going to have our group with neighbor ones and then try to have the biggest group. But one group can have the number of cells, or you can say number of ones, 1, 2, 4, 8, 16, meanings that it must follow the 2 power n rule for number of ones in a one group. And then within one this loop, we can actually also have the open loops to increase, to maximize our group. And then when we write the solution, the value which is changing is out. The value which is persistent, that will be included. For example, for this, our biggest loop, only D value is 0. So D value 0 means that D bar is the solution. And for this one here, you can see that A changing from 0 to A, 0 to 1, B is still 1, so B. C is 0, so C bar. A changes from 0 to 1. And in this third loop, A and B are the same, so A, B bar, because it's a 1, 0. C remains 1, so C. D changes from 1 to 0, so this is out. A, B bar, C. So then our solution is D bar plus B, C bar plus A, B bar, C. So these three terms can also justify all of this Boolean expression with 11 terms. So this is actually the advantage of K-maps. I hope you understand. If you do not understand or you do have a question, please leave your questions in the comments section and we will reply. Thank you very much for watching.